Okay, we're going to be talking about some story problems and quadratic, and basically how to solve a story problem with some quadratic equations. So here we've got a question where I've got the area of a rectangle is 27 square meters, and the length of the rectangle is 3 meters less than twice the width. Find the dimensions of the rectangle. With something like this, what we're going to discover is that we need to set this up first. And whenever I've got a shape, I always like to begin with drawing a picture. In this case, I'm going to draw my picture of a rectangle, and I've got my width here, I've got my length, and the space contained is the area. Of course, area is equal to length times width. Now, the other thing here is we know that the length of the rectangle is 3 meters less than twice the width. So this is going to be 3 meters less than twice the width. We also know that my area here is 27 square meters. So we're going to plug these pieces into our equation here and solve. So I've got my area is 27 meters, or 27 square meters, I should say. I'm going to switch this around. So I've got my width here first, and I'll have my length, because most folks are used to seeing something more in this format, where you've got just a single variable up front instead of a single variable behind here. But let's go ahead and do this. Now I have something that we can go ahead and solve. I can distribute this. So I've got 27 is equal to, this is going to be 2w squared minus 3w. This is something that we know how to solve. I'll be able to move this 27 over to the other side. So I'm going to subtract 27 from both sides. I'll have 0 is equal to 2w squared minus 3w minus 27. And from here, it's just a matter of factoring and solving. It looks like my key number is going to be 2 times negative 27. That's negative 54. And I need a factor pair of negative 54 that adds up to be negative 3. Well, let's see. 1 and negative 54, no. 2 and negative 27, no. 3 times, what would that be? 24? No, actually, how about 18? 3 times 18, no. 4 doesn't go into that, 5 doesn't go into that, but 6 does. 6 would go in here. It looks like 6 goes in here 9 times, and there we have it. So 2w squared plus 6w minus 9w minus 27. And I'll just keep factoring. I'll take out my greatest common factor, so w plus 3. Looks like I can take a negative 9 out of these, and w plus 3. So when I solve this, or when I factor this, I've got w plus 3 times 2w minus 9, and this is still equal to 0. So when I set each individual factor equal to 0, so I've got w plus 3 equal to 0, I'd end up with w equals negative 3, or 2w minus 9 equals 0. So 2w could be equal to 9, or w is 9 halves, or we might even think of that as 4.5. Here is one of the things that we now have to think about. I'm referring to dimensions of a rectangle. So because I'm dealing with dimensions of a rectangle, I'm going to say I cannot have a negative width. And also, I'm also going to note that I have my length up here, that this length was twice my width minus 3. So my length is twice, I'll say this is 2 times that 9 halves minus 3. Oh, that's going to be nice. It'd be 9 minus 3. So my length is 6. Almost done. Now we have to answer our question, and we'll have to say that my width is 4.5. Our units were meters, and our length is 6 meters. So when we're looking at that, you're not always going to go with whatever numbers are whole numbers. Sometimes the fraction is in fact the correct answer. So 4.5 meters and 6 meters. And that is how a lot of these will play out. Sometimes they're going to be fractions. Let's do one more, and then I'll leave off. And I've got another rectangle here. The area of a rectangle is 35 square feet. And the length of the rectangle is 3 feet more than double the width. So once again, I've got my rectangle. I know that it's 35 square feet. Got my width here, and my length is 3 feet more than, so this is going to be a plus, double the width. So this is going to be 3 feet more than double the width. So once again, my area here is my length times the width. I know that my area here is 35. And I'll do this as width times length. So it's 2w plus 3. And once again, we get to do the same thing. I am just going to distribute this through. So I've got 2w squared plus 3w. I'll move my 35 over. So I've got 0 is equal to 2w squared plus 3w minus 35. And it looks like my key number here I'm looking for is going to be 2 times negative 35. That would be negative 70. Without belaboring this too much, something that would multiply to be negative 70 and add together to be 3 would be, say, negative 7 and 10. So I could say, oh, that's 2w squared minus 7w plus 10w minus 35. And once again, we'll factor out our greatest common factor. And it looks like I could take a 5 out from these. So I'll have 2w minus 7 again. So I've got 2w minus 7 times my w plus 5. And this is still equal to 0. We set each factor equal to 0. So I've got 2w minus 7 equals 0. Add 7 to both sides here. I've got 2w is equal to 7 and divide by 2. So I've got w is equal to 7 halves, or I could think of that as 3.5, 3.5. And once again, if I were to subtract 5 from both sides, I'd end up with w could be a negative 5, and mathematically that would work out, but logically, I have no negative dimensions. So I've got no negative width. Since I've got my width here is 7.5, now I'm going to go over here and say, oh, my length was 2w plus 3. That means I've got 2 times that 7 halves plus 3. My 2's cancel. I've got my length is 7 plus 3, or 10. So now I can say that my width is 3.5, or 3.5 feet, since those are my dimensions. And my length is 10 feet. And if I multiply those together, I could clearly see that would be 35. And, twice 3.5 is 7, plus 3 would be 10. It fits all of our criteria, and there's our answer. Alrighty, that's all I've got for now. I will see you in the next video.